This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 2, Control Loops, PID, Temperature Reset, and the Economizer. Lesson 1, Size the valves and dampers. This lesson is the logic that moves them. We'll walk the closed feedback loop, see how gain and reset shape the correction, use reset to slide a set point off outdoor air, and then run the economizer's mixed air temperature, the one number the exam makes you compute here. Concept: open versus closed loop. An open loop acts on a schedule or a command and never checks the result. A closed or feedback loop measures the controlled variable and feeds it back. The handbook wants 3 parts in it: a sensor, a controller, and a controlled device. The set point enters the controller. The controller compares it to the sensed value. That gap is the offset, and drives the controlled device, a valve or a damper, which acts on the process. The sensor reads the result and returns it to the controller, closing the loop. Concept: proportional, PI, and PID. The 3 actions build on each other. Proportional moves the output in proportion to the offset. Simple, but it settles with a permanent offset, because it needs a standing error to hold any output away from mid-stroke. PI adds integral action, called reset, which keeps nudging the output until that offset goes to 0. Most HVAC loops are PI. PID adds derivative, responding to the rate of change to blunt overshoot, rarely needed on slow thermal loops. And these loops run as software in a digital controller, so switching P to PI is a configuration change, not a rewire. Concept: gain and proportional band. Gain is how hard the loop reacts to a deviation, percent change in control signal over percent change in control variable. The proportional band, the throttling range, is the flip side, the span of the controlled variable over which the output travels the full 0 to 100%. The handbook states the link in words: the band is inversely proportional to the gain, so a wide band means low gain, sluggish, with a larger standing offset. A narrow band means high gain, tight, but it can hunt, and reset is what erases the offset a proportional-only loop leaves behind. Concept: reset or compensation control. Compensation control adjusts a set point based on a second measured variable. The classic case is an outdoor air reset schedule on a hot water supply. As it warms up outside, the loop resets the supply water set point downward, so the plant makes only the water the building actually needs. Cold outside, higher supply set point. Mild outside, lower. Watch the word here. This reset shifts a set point. It is not the integral reset of a PI loop. Concept: the air side economizer. Below a high limit setting, the outdoor air and return air dampers modulate in sequence to hold the supply temperature. And that cuts mechanical cooling. An integrated economizer runs alongside the chiller for partial free cooling. A non-integrated one locks out once mechanical cooling starts. The high-limit control decides when to lock the economizer out, and it comes 2 ways. Dry bulb, fixed or differential, switches on temperature alone. Enthalpy, fixed, differential, or electronic, switches on total heat, and it's the better choice in humid climates, where cool but moist air still carries a large latent load. Setup: the economizer's mixed air temperature. In the mixing plenum, the outdoor stream blends with the return stream, and an energy balance on the total flow gives the mixed air temperature. The outdoor flow fraction times the outdoor temperature, plus the return flow fraction times the return temperature. Those are flow fractions, and they have to sum to 1. Our givens: 40% outdoor air at 50 degrees, 60% return air at 75. The handbook applies this balance when the 2 streams differ by more than 20 degrees. Ours are 25 apart. Solve: the mixed air temperature. Weight each stream temperature by its flow fraction and add 0.4 times 50 plus 0.6 times 75. 65 degrees. It lands between the 2 stream temperatures, pulled toward the larger return air fraction, which is exactly what a weighted average should do. And the outdoor air fraction is what the economizer modulates. Drive it to 100%, and the mixed air temperature is just the outdoor temperature. Traps: 5. 1. Proportional band is inversely proportional to gain. Wide band, low gain, sluggish with a larger standing offset. Narrow band, high gain, tight but it can hunt. And only the gain equation is printed. The band relationship is stated in words. 2. There are two different resets. Integral reset in a PI loop erases the offset a P-only loop leaves. Temperature reset shifts a set point off a second variable. Same word, different mechanism. 3. The economizer high limit is dry bulb or enthalpy. Enthalpy is the humid climate choice, where cool but moist outdoor air would sneak past a dry bulb limit. 4. Mixed air temperature is flow-weighted, never a plain average, and it always lands between the two stream temperatures. 5. PID tuning is not a handbook formula. You get the definitions and the response curves, nothing to plug in. Quick recall. A closed loop is a sensor, a controller, and a controlled device, with feedback correcting the offset. Gain is percent signal over percent variable, and the proportional band is inversely proportional to it. Integral reset removes the offset. Temperature reset shifts a set point off outdoor air. The economizer opens the outdoor air damper below a dry bulb or enthalpy high limit for free cooling. And the mixed air temperature is the outdoor fraction times the outdoor temperature plus the return fraction times the return temperature. Golden rule: gain and band move opposite ways, and mixed air is a flow-weighted average, never a plain mean. Next up, Lesson 3. HVAC System Types. Single duct constant volume and reheat. With the control logic in hand, we start assembling it into systems. We'll read the Handbook's central system diagram, mixed air section, coils, fans, and the single duct constant volume reheat terminal where a space thermostat trims a reheat coil. It's concept and diagram driven, so expect to read the schematic question. Everything's at PEPrepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.